ester. So here in this ester group we have alpha and beta position unsaturation. What are the catalysts we are using in this reaction? Palladium acetate, OAC. AC mean acetate, acetate group probably. CH3, CO carbonyl O minus. So this is the acetate from acetic acid. The acetic acid lose the proton, we get the acetate, palladium acetate. So in presence of base condition, this reaction take place at base condition. When a base we have the alkalic base like sodium hydroxide, potassium hydroxide, whatever it may be. So these bases are using in this reaction also. So coming to this signification, the signal. So generally the sonication reaction show like this. So this is a wave. We can write like this. This indicates sonication reaction. So in bottom we are writing this line. So this is indicate the sonication reaction especially. So this is about the reactants of egg reactions. First of all, we take the bromobenzene, the simple compound bromobenzene, and this is alpha beta unsaturated esters. Alpha beta unsaturated ester. What are the catalysts we are using? Palladium acetate. Palladium acetate. Presence of base. So this is indicate the sonication reaction. So what are the product we are getting from? Simply this is very simple reaction. We lose the hydrobromine from here, bromine, and this one H from CH2 we lose H. So that's why we can write like this CH. After that this CH addition here, CH and directly attached with benzene. So the remaining group HBr. So this is the reaction spot. So remaining everything is chain, not chain. Sorry, only the reaction spot is chain. For example, the bromine is substituted by the this one. The bromine is substituted by the CH. The CH is directly bond with the benzene. So after that the H and B are lost here from HBr. So these are the product we are getting and substituted benzene ester. So this is the egg reaction under insonication conditions. So coming to this Hans-Decker reaction, this is also very simple reaction. Hans-Decker reaction. We take the um, silver carboxylates. Silver carboxylates. So generally this is the reactant we are using, silver carboxylates. The silver carboxylate from carboxylic acid reaction with silver chloride like that. So we are getting the silver carboxylate. Silver carboxylate. So this is the carboxylic acid generally, RCOOH. From RCOOH, so we can substitute this silver group, hydrogen by the silver group. So that is a silver carboxylate reactant. Silver carboxylate reactant. This silver carboxylate reactant reaction with bromine under the sonication condition. So these are the reactants we are using in this reaction. What is happening? Very simple. We break down the bond between the oxygen and silver. Silver have positive charge and oxygen negative charge. And this is also, we can break bond from here also. So after that the carbon dioxide, we lose from carbon dioxide from this carboxylate group. Carbon dioxide from this carboxylate group. What is happening? So what is the charge on silver? So generally silver positive charge, the bromine addition here, silver bromide, and then the remaining bromine also reaction with this alkyl group, R plus group, alkyl group to form RBr. To form RBr. RBr mean any one of the alkyl group, like if you take methyl or ethyl, So these are the hydrocarbon group, R mean hydrocarbon group. So what are the product here? Generally, it is a alkyl halides. Alkyl halides are the product in these reactions. We take a simple example for this reaction. Silver estate. So this is the silver estate reaction. Silver estate reaction with bromine. What are the product we are getting? So first of all, we lose the carbon dioxide, CO2, plus the silver reaction with one of bromine to form silver bromide, plus the remaining methyl group reaction with bromine to form methyl bromide. So these are the three products are we are getting from this reaction. Simply we can write like this. First of all, methyl bromide and plus carbon dioxide plus silver bromide. So this is the products we are getting for this reaction. Second one, Witting reaction. Witting reaction also, it is a Witting coupling reaction. So we can couple the two molecules with the help of pi bond or double bond. And one sigma bond is there and one pi bond is there. Generally, it is a double bond connecting with a double bond. For example, here this is what is the compound of this? Anyone? ఏంటండి ఇది ఏం ఫంక్షనల్ గ్రూప్ చెప్పండి? RCOR ఏంటండి? So generally carbonyl compounds are two types. The carbonyl compounds అంటే just what are the functional group present in carbonyl compound? CO, carbonyl group. So this one aldehyde or ketone?
Ketone, sir.
Ketone. Ketone అది reaction with ketone reaction with phosphonium yield ఇది phosphonium yield. So in phosphonium yield phosphonium yield అంటారండి దీన్ని. The name of this reactant is phosphonium yield. Phosphonium yield, it is a quaternary salt of phosphonium yield. This phosphonium yield reaction with ketone is very simple reaction. So we lose the triphenyl phosphonium oxide. This is the triphenyl phosphonium oxide. After that, the new bond, double bond form with two carbons between the two carbons. So this is finally we are getting the alkene product. Very simple reaction. For example, first of all, here what are the reactants in these Witting reactions we are using? The first one, ketone. The second one, phosphonium yield. This phosphonium yield and this one ketone. The phosphonium yield reaction with ketone to form alkene plus phosphonium oxide. Very simple reaction. What is happening in this reaction? Here, triphenyl phosphine. P mean phosphine rabo, phosphorus telusuga we know. PH3 mean phenyl group. Phenyl group mean so the benzene. So the benzene ring. So we know loss of one proton C6H5 ని మనం ఫినైల్ గ్రూప్ అంటారండి. ఇక్కడ PH రాశారు కదా, అదే ఫినైల్ గ్రూప్. సో దిస్ ట్రైఫినైల్ phosphine finally phosphonium yield reaction with this ketone to form triphenyl phosphonium oxide plus alkene. Very simple reaction. We take one of the examples also. Here what are the product we are getting చెప్పండి. ఏమొస్తుంది ఇందులో ప్రోడక్ట్ ఏమొస్తుంది అక్కడండి? ఇక్కడ కూడా సింపుల్గా ఏం లేదు. పాస్పోనియం ట్రైఫినైల్ పాస్పోనియం ఆక్సైడ్ వెళ్ళిపోయిన తర్వాత ఆఫ్టర్ దట్ ద న్యూ బాండ్ డబల్ బాండ్ ఫామ్ బిట్వీన్ ద టూ కార్బన్స్. అదే ఇక్కడ రాసాము. ఏమొస్తుందండి ఇక్కడ ప్రోడక్ట్ ఇక్కడ రాస్తాను నేను, చూడండి. ఒక్క నిమిషం. Carbon between the two double bonds. This carbon have CH3 and CH3. So here and CH3. So here this carbon connecting with C2H5 and CH3. So one of the C2H5 from here, one of the CH3. So finally we are getting this alkene product. So in sonication reaction we have only 3 sonication reactions. One is egg reaction, వెరీ ఇంపార్టెంట్ అండి. ఇవి 3 రియాక్షన్స్ వస్తాయి ఎగ్జామ్లో మీకు. మనకున్న సిలబసే చాలా తక్కువ కాబట్టి కమింగ్ టు ఎగ్జామినేషన్ పాయింట్ ఆఫ్ వ్యూలో వాట్ ఆర్ ద సోనికేషన్ రియాక్షన్స్ అంటే, సో ఈ 3 రియాక్షన్సే ఉన్నాయి మీకు. ఎగ్ రియాక్షన్ అండ్ ఆన్స్ డీకర్ రియాక్షన్ అండ్ వెట్టింగ్ రియాక్షన్. సో దిస్ 3 రియాక్షన్ వెరీ సింపుల్ రియాక్షన్స్. మీరు అవి ఈజీగానే గుర్తుంచుకోవచ్చు, పెద్ద ప్రాబ్లం ఏం కాదు వాటికి. నెక్స్ట్ సో రియాక్షన్స్ ఇన్ అయానిక్ లిక్విడ్స్. వాటర్ మాలిక్యూల్స్ అయిపోయింది, అది కాలేదు కదా. రియాక్షన్స్ ఇన్ వాటర్ కాలేదు. వాటర్ యాజ్ ఏ సాల్వెంట్గా కొన్ని రియాక్షన్స్ ఉన్నాయి మనకు. సో నో వెనగల్ కండెన్సేషన్, ఇందులో మొత్తం వీఆర్ యూజింగ్ వాటర్ యాజ్ ఏ సాల్వెంట్ అండి. ఇవి కూడా చాలా ఇంపార్టెంట్. వాటర్ యాజ్ ఏ సాల్వెంట్గా ఉన్న రియాక్షన్స్ ఇవి. వాటర్ యాజ్ ఏ సాల్వెంట్గా ఉన్న రియాక్షన్స్ వచ్చేసి మనకు 3 రియాక్షన్స్ ఉన్నాయి. నో వెనగల్ కండెన్సేషన్, బ్రోమినేషన్ రియాక్షన్ అండ్ డీల్ సాల్డర్ రియాక్షన్. సో వాటర్ యాజ్ ఏ సాల్వెంట్. ఫస్ట్ ఆఫ్ ఆల్ what are the character of water molecule? Water ఏంటి? it is a polar solvent or non-polar solvent? H2O polar solvent or non-polar solvent? అది hello, polar mean ions, so it forms the ions and H plus and polar or non-polar అండి. అది 9 మెంబర్స్ వచ్చారు మాకు. H2 అనేది పోలార్ కాంపౌండ్ అండి. సో సాల్ట్ మీరు లైక్ ఇఫ్ యూ టేక్ సాల్ట్, టేబుల్ సాల్ట్ మాలిక్యులర్ ఫార్ములా ఏంటండి? టేబుల్ సాల్ట్ NaCl అనేది పోలార్ ఆర్ నాన్ పోలార్? పోలార్ మీన్ అయాన్స్ ఫార్మేషన్, Na plus and Cl minus, because of their electronegativity differences to form the ions Na plus and Cl minus. So here also same like that. Polar water is a polar compound. First of all, waterలో soluble కావాలంటే all organic compounds are non-soluble in water, because water is a polar compound and organic compounds are non-polar compounds. So if you take petrol or kerosene, it does not dissolve in water because of petrol or petrochemicals compounds all are formed with hydrocarbons. So that's why there is no polar bonds, there is no polarization, like all are made with only carbon and hydrogen. So that's why there is no soluble in the water. So that's why we are introducing the polar groups on the hydrocarbons. At that time it is easily soluble in the water. For example here, so the benzene does not dissolve in soluble in water, but we are introduce the carbonyl group on the benzene, so that carbonyl group act as a polar group, so it is little bit soluble in water. So here also same. So the nitro group and cyanide groups, these both groups are polar groups, so that's why it is easily soluble in water. So especially these reactants, very special reactants we are using in this reaction. So we have so many no venegal condensation reaction, but all are not conducting in the water as a solvent. So especially these reactions are these reactants are we are using as a water as a solvent. Because of water is a polar compound, it is H plus and OH minus ion having. So that's why the reactants also soluble in water. So that is the first condition. So if you take any hydrocarbon, it does not be soluble in water. So at that time we can introduce the polar groups on the hydrocarbon chain. So after that, so we can conduct these reactions. So this is the benzaldehyde. Benzaldehyde also less soluble in water, but we take here benzaldehyde, and this one nitro and cyanide substituted methylene group. The nitro and cyanide, these both groups are polar groups, so that's why it is easily soluble in water. So this reaction, a very simple reaction. ఇక్కడ ఏం లేదు మీకు, just loss of water molecule from both of the molecule. Condensation mean, so we lose condensation mean we can connection between these two molecules with the loss of water molecule. వాటర్ మాలిక్యూల్ లూజ్ చేస్తూ లాస్ అవుతుంది. ఇందులో ఏం లేదు, సింపుల్ రియాక్ట్ ఫ్రమ్ H2 and CO. So we make a new double bond between the two carbons. So this is the alkene derivative product. Finally we are getting this reaction take place at room temperature, and it take time 7 hours. The yield of this product also 90% of the yield we are getting this reaction. Very simple reaction. The condensation of the two, so this is happening, the two reactants loss of water molecule from the um, oxygen, and here one of the benzaldehyde lose the oxygen, this one methylene active methylene compound lose the H2 from. So finally we are condensed these two compounds with new double bond between the two carbons. So this is the product now, chemical condensation. The second one, bromination reactions. Bromination reactions also, here also same thing. We are introducing the cyanide and OH group in benzene, especially because of benzene does not dissolve and soluble in water. So that's why we are introduced the polar groups on the benzene. అలాంటప్పుడు అదేమైతే ఈజీలీ సాల్బుల్ ఇన్ వాటర్. సైనైడ్ గ్రూప్ అనేది ఇట్ ఈస్ ఏ పోలార్ గ్రూప్, అండ్ ఓహెచ్ అనేది పోలార్ గ్రూప్, కాబట్టి ఈజీగా సాల్బుల్ ఇన్ వాటర్ అవుతుంది. అండ్ బ్రోమినేషన్ మనం ఏమేమి తీసుకున్నాం, సోడియం బోరైడ్ బ్రోమైడ్, ఇట్ ఈస్ ఆల్సో సాల్బుల్, అండ్ సోడియం బోరేట్, ఇది కూడా సాల్బుల్ వాటర్ ఇన్ HCl ఆల్సో సాల్బుల్ ఇన్ వాటర్. So this reaction takes place at room temperature at it's take time 4 to 5 hours. The percentage of yield of this product 97%. Generally in bromination reaction, especially in bromination reactions or halogenation reactions, in benzene, engine at ortho position take place. Ortho position of the electron donating group. So here we have the two groups. One is the cyanide group, another one the OH group. Cyanide is the electron withdrawing group. According to mesomeric effect, cyanide is the electron withdrawing group. So that's we minus Me antam manam, negative mesomeric effect group. At the same time OH is the electron donating group. Donating withdrawing, which mean, so the electron pair of electron donating to the ring mean it is a benzene ring. So if the any substitution pair of electrons are donating to the ring, so that is the donating group. If the withdrawing group means, so we can discharge the benzene ring charge, so that is the withdrawing group. So halogenation reactions are electrophilic substitution reactions. Electrophilic substitution reaction mean electrophile, generally what are the charge on electrophile? Electrophile పైన ఏ charge ఉంటుంది? Positive charge. So it is always at easy going to the electron rich places. ఎక్కడైతే ఎలక్ట్రాన్ రిచ్ ఉంటుందో ఇన్ రింగ్లో అక్కడికి వెళ్తానికి అది ఇష్టపడుతుంది. బికాస్ ఆఫ్ దెర్ ఈజ్ ఎలక్ట్రాన్ డెఫిషియన్సీ. ఎలక్ట్రోఫైల్ మీన్ సో ఇట్ అట్రాక్ట్ ద electrons. So that's why here the OH group is electron donating group and cyanide group is the electron withdrawing group. If you bromine plus ion, bromanium ion going to cyanide adjacent carbon, so what is happening? The cyanide already withdraw the electrons from the carbon, so that's why there is no electrons is found. So when the bromanium ion coming to OH group ortho position, so it is electron rich because of the OH group electron donating to the ortho position of the benzene. So that's why the bromine substitution on the ortho position of the OH group. Ortho position of the OH group. So not at the ortho position of the cyanide group. So this is happening. So generally the mono substituted benzene we have the three positions. So this is a benzene mono substitution. If you take X like X తీసుకున్నారనుకోండి, ఇది ఆర్థో అండ్ మెటా పారా పొజిషన్స్. సో ఇయర్ ద ఓహెచ్కి ఇక్కడ వచ్చేసి ఇది ఆర్థో పొజిషన్స్, బోత్ సైడ్స్ బ్రోమిన్ ఎడిషన్ అవుతుంది. సింపుల్ రియాక్షనే. ఇంకా నెక్స్ట్ డీల్-సాల్టర్ రియాక్షన్. దిస్ డీల్-సాల్టర్ రియాక్షన్ ఎస్పెషల్లీ not first one. For example, we are preparing cyclohexane. So the cyclohexane is we are using 1,3 butadiene and plus ethene to prepare the cyclohexane. The total